Hey, quick thought. What if we could see infrared all the time? Let's think through this like a scientist with a flashlight and no drama. Infrared is just another kind of light. It's the light things give off because they're warm. We don't see it now, so warm things look plain. If our eyes suddenly picked it up, we would be adding a new layer to what already hits our retinas, like turning on a second TV behind the first one. First intuition to drop. This is not X-ray vision. Infrared is low energy. It shows surface temperature and heat flow, not bones or secrets. You wouldn't suddenly read a book through a wall. You'd see heat patterns on the surfaces you can already see. Now, the fun physics in plain clothes. A human at normal body temperature and a hot mug differ only a little in total thermal glow. Your skin is about 37 degrees Celsius. A just-poured mug might be 60 degrees Celsius. That's not 10 times brighter, it's more like a third brighter. So a steaming cup would stand out, but it wouldn't blind you. Think a hot mug would be noticeably brighter than a hand, but not like a headlamp. That's because the amount of thermal light climbs quickly with temperature, but everyday temperatures are all in a narrow band.
Scales matter. Thermal glow spreads out and gets lost in the air. A warm human or car engine is easy to pick out at a few meters. At tens of meters, you still see contrast if it's significantly warmer than the background. At city street distances, everything that's been sitting in the sun, pavement, buildings, cars, gives off a steady glow, so the scene becomes a tapestry of warm and cool patches rather than sharp objects floating in blackness. Time. Heat changes slowly compared with visible flashes. A kettle cools over minutes. Your skin reddens in seconds when you blush, but overall, thermal contrast drifts on human timescales. So you'd notice slow breathing as a faint rhythm in a close-up face, and you could watch a pizza cool over several minutes if you were obsessively attentive. Flames and electronics change faster. Those are the flashy ones. What would the world look like? Nights would change the most. Right now, night is mostly empty of photons from nearby objects. With infrared vision, warm bodies, car engines, lamps, and sun-warmed streets would show up as glowing shapes. Some animals that are invisible at night to our eyes would stand out like lit signs. On a clear, cold night, warm people would glow clearly against the cool background. On a hot summer night, everything glows, and contrast drops, like trying to find a white shirt in a room lit uniformly by dim lamps. Materials would betray different secrets. Some fabrics and thin materials that look opaque in visible light let a lot of thermal light through, so they'd appear more translucent. Other things that look transparent, certain glasses, can block a lot of infrared. So what looks the same today would split into visible appearance and thermal appearance. Artists and designers would get a new toolbox. Also, objects that waste energy, radiators, leaky windows, hot spots on electronics, would be obvious without instruments. A small calculation to keep intuition honest. Think of skin at about 37 degrees Celsius and a mug at about 60 degrees Celsius. Converting to the absolute scale that physics cares about, Kelvin, and comparing the emitted thermal power gives you roughly a 1/3 increase for the mug over the person. Not an order of magnitude, just a noticeable bump. In plain language, hotter means brighter, but normal human temperatures and hot beverages live in the same neighborhood, not different countries. Some practical consequences. No moralizing, just observation. Fever becomes a brighter face from a short distance. A kettle, radiator, or running laptop becomes a small sun in your peripheral vision. Incandescent things, old bulbs, stovetops, that waste energy as heat would look much more dramatic than LEDs do. Nighttime navigation would change.
Road signs and reflective paint still help, but so would heat outlines from cars and engines. People who work with heat, plumbers, mechanics, electricians, would get a huge advantage. Also, you'd probably avoid touching a metal bench at noon without thinking about it. Small point. A quick aside, because I can't help myself, our brains are remarkably good at learning new mappings. If you grew up seeing infrared, you wouldn't see redder people as scary, you'd see a different set of cues and quickly treat them as normal. Which is to say, the awkwardness would be cultural, not optical.
Finally, the limit cases. You wouldn't see through thick walls, and you wouldn't detect cold things that don't give off much thermal radiation. You also wouldn't magically make the night as detailed as daytime color vision. You'd gain a powerful complementary sense of heat patterns, not replace the details color gives you about pigment and reflectance. So the slightly surprising conclusion, if we could always see infrared, the world wouldn't become a sci-fi X-rayed panorama. It would become a second, steady map layered over what we already see. A map of warmth, leaks, engines, and slow flows of energy. Nights get richer. Some objects go from invisible to obvious, and ordinary scenes look like thermal cartoons of themselves. You'd still need light to read by, but you'd never again be surprised by a hot cup of coffee.